Hello everybody, welcome to this vlog. My name is Satya. In this vlog, we will discuss about virtual route forwarding concept. So to explain this virtual route forwarding concept, I have shared a topology diagram wherein PC1 with IP address 192.168.1.2 with a subnet mask of /24 is connected to router 1 on ZG0/0 port of router 1. Then there is a direct link connection within the router 1. G0/1 is connected to G0/2. G0/1 as an IP address in the VRF 1 with 10.0.0.1 and 0/2 in VRF 2 as an IP address 10.0.0.2/30. Okay, then we have PC2 connected directly to router 1 using G0/3 port, and PC2 IP address is 192.168.2.2 with subnet mask as /24, and router 1 G0/3 port as subnet IP address 192.168.2.1 with subnet mask of /24. So now, what do you mean by virtual route forwarding concept? Instead of using two routers right here, instead of using two routers, router 1 and router 2, I'm creating a virtual routing instance VRF1 and VRF2 within router 1. There I segregate VRF1 to route between 192.168.1.0/24 segment to 192.168.2.1/24 VRF2 segment. So we have two VRFs, but the VRF is local to the router itself, right? PC1 will never understand that there is a VRF in the router 1, right? So then here you see there is a direct physical connection between G0/1 and G0/2 on router 1 itself. Both have the same IP address, but they are belonging to two different VRFs. G0/1 is belonging to VRF 1 and G0/2 is belonging to VRF2, right? So that's why overlapping IP addresses is possible. So we learned two things here. One is within the same router we can have two separate routing entries so that they can route the packets between two subnets, and the same subnet can be used for interconnection from VRF1 to VRF2 within router 1. So let's analyze packet by packet. Now IP address 192.168.1.2 is given to PC1. Router 1, you have an IP address on G0/G which is mapped to VRF1 as IP address 192.168.1.1. Now here on PC1 we need to create a default route. I have explained in detail the routing concepts in the previous videos. Please visit that video and try to get acquainted with this default route concept. So while defining a default route on PC1, I say 0.0.0.0/0, right? That means to say this default route points to a default gateway uplink which is 192.168.1.1 for PC1. So any packet other than 192.168.1.0 subnet will be sent to default gateway, right? So first it has to do ARP resolution. So PC1 will send an ARP message saying who has 192.168.1.1. Once he gets a response saying 192.168.1.1 is physically on G0/0 interface with this MAC address, he'll reply to PC1. PC1 will come to know that, but we are trying to reach PC1 to PC2, that is 192.168.2.2. So PC1 knows about 192.168.2.2 through 192.168.1.1, right? So once he gets ARP response, he populates source address as 192.168.1.2, Destination address has 192.168.2.2, which will not get changed during the traversal. Only the MAC address gets changed. The destination MAC is the G0/0 interface MAC address. The packet will come on VRF router 1. He sees that in VRF 1 there is 192.168.1.1 interface, right? And that MAC address is also mapped to G0/0, which is in VRF 1 interface, right? So the VRF 1 table has a routing entry that to reach 192.168.2.2 you need to go through 10.0.0.1 interface, that is G0/1 interface. So what he will do, he will send an ARP packet saying who has 10.0.0.2 inform 10.0.0.1, right? So since it's a direct connected link, it will arrive on VRF2. VRF2 knows that 10.0.0.2 is G0/2. He will respond with ARP response with the MAC address of G0/2. Once the MAC address is known, here the packet with source address 192.168.1.2, which is will not be changed. Destination address will be 192.168.2.2, which will also be not changed, but the destination MAC here will be the G0/2 MAC address. Okay, so then the packet will arrive here on G0/2. G0/2 is mapped to VRF2 routing table. There he will check to reach 192.168.2.2 which interface to take. It is G0/3. He will send on 0/3 interface who ARP message saying who has 192.168.2.2 tell 192.168.2.1 interface. Once PC2 responds with its MAC address, a packet with source address 192.168.1.2, destination address 192.168.2.2, but now the actual destination MAC address will be populated and sent to PC2. This is the ICMP request. Here now when he responds to ICMP request with ICMP reply, PC2 sees that in its routing table there has to be a default route 0.0.0.0.0/0 pointing to 192.168.2.1, right? So already we have received a packet from 192.168.2.1, so he will not send an ARP. There will be a ARP entry for it, so he will just send the packet by populating the destination MAC address as G0/3 interface of router 1. So here now the source address will be 192.168.2.2 in echo reply, and destination address will be 192.168.1.2, right? Destination MAC will be G0/3. Once it comes here, it's on G0/3 is on VRF2. He will see how to reach 192.168.1.2. To reach 192.168.1.2, he has to reach G0/1, that is 10.0.0.1 gateway. So then he will send an ARP response who has 10.0.0.1 inform 10.0.0.2 on G0/2. So G0/1 MAC address will be provided. Here the source address will not be changed. It will still remain in echo reply as 192.168.2.2. Destination address will be 192.168.1.2. Destination MAC will be G0/1. Once it reaches 0/1, 0/1 is on VRF1. Then he sees that in VRF routing table how to reach 1.2. It is directly connected PC1. He will send an he will still be having an ARP entry for 1.2. So he will send a packet with ICMP echo reply. Source address is 192.168.2.2. Destination address is 192.168.1.2. Source address has 2.2 and destination address has 1.2. Destination MAC is actual MAC address of the PC1. Then echo reply will be, so that's how the communication happens. So here I'm explaining ICMP. There might be a UDP packet, TCP packet. That's how the communication will happen. in this VRF instance. So the main thing that you have to keep in mind is using a single router, right? We can use different virtual routing interfaces logically so that a packet will be routed from one subnet to other subnet, and use the same overlapping subnets in VRF1 and VRF2, two different VRFs. That is, here we are using overlapping subnets in G0/1 and G0/2. If we don't use VRF concept, then this definition of uh, same subnet definition on two different interfaces is not allowed. It will give an error saying subnet is already used by different interface. So you need to put it in different VRFs so that overlapping subnets can be used. So this is what I wanted to discuss as part of this vlog, the virtual route forwarding concept. So using a single router, how you can achieve multiple subnet traversal, okay, using the same router, was single router in the path, right? Okay, thank you for your time. I will see you in the next vlog.